Next, we're going to talk about physical and chemical properties. We're going to start with talking about elements, and I'm sure many of you know what the elements are. Um, we refer to the elements on the periodic table. There's more than 100 known elements, and 90 of these are occurring naturally. We've also been able to create elements in laboratories in order to enhance our way of life as humans. So here's the periodic table. There are many different periodic tables that you can go to and search online. Um, there are there are ones on Google that you can use, and there's another periodic table that is called PubChem, and it's pubchem.ncbi.nlm.nih.gov, and that's a periodic table that is from the National Library of Medicine in the United States. Uh, and it tells us a lot of information. This is a great periodic table as well, but here's another one. Um, here's another periodic table. Share my screen here. So here's another periodic table that is going to be very useful for this class and chemistry in general. So here we have all of our elements, of course, but we can organize these elements by different properties. We can organize them by atomic mass. We can organize them by our electron configuration, which we're going to go over later in this course. Even the oxidation states, which I believe is a bit challenging to calculate at times. So it's nice to have those on the periodic table. Electronegativity, we're going to go over that in class as well. Atomic radius is important. There's trends for atomic radius where you might not have to use this if you know all the trends for atomic radius, but it's still good that that's there. And then we have melting point, boiling point, density, and some other properties as well. So that's a this is a great periodic table to use. But again, if you have one just from your book, that's fine too. All right, so the symbol is the element, and this is our atomic number, and then the name goes down here. And these are typically color coded with metals, metalloids, and nonmetals. However, there's a lot more than just metals, um, metalloids, and nonmetals. If we're looking more closely at a more detailed periodic table. So with the metals, we have alkali metals, uh, metalloids. So those are not the metals, but we also have actinides, alkaline earth metals, reactive nonmetals, noble gases, transition metals, and post-transition metals. And here's just a quick overview of what all of those are. And again, you can look these up and use these for reference whenever you need to. But this is the periodic table showing the different types of metals and the actinides and lanthanides and the metalloids. So atoms are the smallest particle of an element, and they have that property of the element, and they can enter into a chemical combination. So an atom is the smallest single piece of an element. It was first proposed by Greek philosophers and Democritus in the 5th century BCE. Much later in the 19th century, John Dalton, he supported his hypothesis by measurements and determining what atoms are. Molecules are two or more atoms that are connected by strong forces, and we call those forces chemical bonds. And there's different types of chemical bonds and different types of forces that hold molecules together. Sometimes they're held together with a stronger molecular force, and sometimes it's a very weak molecular force. Sometimes it's both, and there's multiple forces acting on atoms at the same time. Here we have a picture of just gold atoms. This is what this would look like in a microscope from uh, letter B here. And this is what gold looks like, just looking at it, and this is the microscope. So molecules can exist as individual atoms as well. Or excuse me, only a few elements exist as individual atoms. Most elements exist as molecules with two or more atoms of the same element that are bonded together. So hydrogen, we can say diatomic hydrogen, H2, is two atoms of hydrogen bonded together, and that makes diatomic hydrogen. Diatomic oxygen, and here we have phosphorus. There's 4 phosphorus atoms, and sulfur, there's 8 of them, forming the element. Many molecules consist of 2 or more atoms. The very common one, water, H2O, carbon dioxide, and here's glucose. And so you'll notice that the molecules aren't all arranged the same. So for water, we have this bent shape. And for carbon dioxide, this is a linear organization of atoms to form the molecule. And we're going to talk about how to determine what molecules look like as far as their shape later on in this course as well. Pure substances, they have a constant composition. They can't be broken down into a simpler substance by a chemical change. Gold, oxygen, those are pure substances. Compounds can be broken down. So a compound is 2 different atoms. So silver chloride, water are examples of that. We can break them down into their individual elements. And this is an example of when we heat up mercury oxide, it breaks down into elements of mercury and oxygen. So the oxide means oxygen, and so it's breaking it down into 2 different substances. So here's mercury oxide. It's like a yellowish, maybe orange powder. And when we heat it up, it turns into just the mercury, and the oxygen we can't see, but it's in the tube. So it's liquid mercury. Mercury is liquid at room temperature, so that's why that metal is a liquid there. A mixture is composed of 2 or more types of matter, and it can be present in different amounts, and it can be separated by physical changes. Evaporation is a great example of a physical change. If you are to cut something, that's a physical change as well. So physical changes are different than chemical changes. There's 2 types of mixtures: homogeneous mixtures and heterogeneous mixtures. A homogeneous mixture has a uniform composition, and it appears the same throughout. Another term for homogeneous mixture is a solution. A heterogeneous mixture has a composition that varies from different points. So oil and vinegar and salad dressing is a heterogeneous mixture. Its composition's not the same. We can see these oil droplets here in the vinegar, and it's not mixing very well. Here we have a sports drink, which is sugar and water and other flavors, and it's all mixed together evenly, or it's uniform throughout. And so we call this a homogeneous mixture. All right, and here are the practice questions for this section.